At the end of this video, we're gonna find out a memory cell capable to storage 1 bit. We're gonna see it as a unit with 4 terminals. One is the data in and the data out. We're gonna use it for both read and write, also for both actions, open enable and chip select. Recall, this is the basic unit of a memory. This is the memory cell. Then exists arrangement of memory cells and arrangement of memory cells. Let's say I'm gonna read. So for reading, I put here a 1, and well, recall this flip-flop, I respond to a positive 8. That is why I put here a not. So when I have a 1, this unidirectional gate is activated. So whatever is in Q will be transferred to D. As it is unidirectional, what is in D can't be passed through D to Q. So let's say I have in a previous moment a 0. So with a 1, whatever is here goes to D. Whatever is in Q goes to D. So now I can read a 0. And what happens here? When I have a 1, this is the night, so I have a 0. This gate is inactivated. So whatever is here is not passing through here. And that's cool, it's great, because I don't want anything on D. And also, it's not going to obey me, the flip-flop. Because remember, this is with a positive 8. So when I have here a 1 for reading, unclock goes to 0. So here we have a negative 8. Now is when I put a 1, that this one, the clock signal receives a 0. Sorry, here you have a 0 and this clock receives a 1. And now I have a positive 8. And if I have something on D, now it's going to be transferred to Q because now I have a positive 8. So let's say I'm going to write. I could write whatever I can read, but let's say now I'm going to write a 1. This I'm going to put it with green. Let's say I'm writing. So I put a 0, this goes to 1. This is the clock signal. What I see here. So let's say I'm going to write a 1. And with this 0, this gate is inactivated. So it's not going to transfer Q to D. Now here is 0, goes to 1, and now this gate is activated. So this one goes to here and passes to D. And as is in positive 8, what is in D now passes to Q, but stays here in Q. Now, just in Q, I don't have in our data boost. Now is when I read what I just write. Now I'm reading. I have here a 1, clock see a 0, so goes from 1 to 0. It's a negative 8, so my flip-flop will not obey me. And here is a 1. So this gate is activated. So I have here a 1. So whatever is in Q goes to D, and now here I'm able to see a 1. But what happens here? I have a 1, so goes to 0. This gate is inactivated. So I don't care what is here, which is 1. I don't care. I'm not going to let pass here. Also, flip-flop is not going to answer to me because it's in a negative 8. That is the mechanism how I can read and how I can write. But I can add more instructions to able to control this in a matrix, like to habilitate it or not to habilitate it. And here is where I'm gonna introduce chip select and output enable. But first, let us start with output enable. The mechanism, the function of this system It's going to still happen, but I'm not going to be able to see it reflected on the data. Before to continue, I want to stare at something. When I have a 1 and this goes to 0, I have ambiguity. This goes to third state. And the less I'm going to have is ambiguity. So here in this point, I will put a pull up that forces a data. I don't care. I don't care because my flip flop is going to be inactivated when here is on third state. So I don't care if it is a 0 or if it is a 1. So I put here a pull up. And the pull up pulls me up the voltage. If it is a 1, states 1. But if it is a 0, 0 kills 1. So I will have a 0. But really, as I said, I don't care because it's going to be on the negative edge, my clock of the flip flop. So don't worry. In practice, this is super important. We are going to see that if we don't have this pull up, our memory read and write will not function. My output enable is denied. So anytime I want to enable my output, I set this to 0. When output enable is in 0, my trigger is going to be read and write. Because if it is in 0, it's going to have a 1, the AND. And if it is 1, that we are going to be reading. If it is 0, we are going to be writing. Because this is in 1. Now, when output enable is in 1, this goes to 0. And I don't care what is in read and write, this gate is going to be off. Our cell is always going to be writing. It's not going to be able to read. And it's okay because I'm inhabilitating the output, the data bus. Now, if I want to deactivate the whole cell, I use chip select. When it is in 0, I'm selecting the cell to function, and this goes to 1, so the functionality is exactly the same. Whatever happens here in read and write, and if only if output enable is activated, read and write is going to tell the functionality. I'm going to read, I'm going to write until cell will obey to that. But when chip select is inactivated, this means when it is in 1, here I have a 0. And now the trigger is not going to be read and write because now the clock is not going to receive any signal telling when to transfer D to Q. And recall that here, when it is in 0, we are going to have third state, and we don't have that ambiguity. So again, we put here a pull up. I don't tell when I say this pull up, but pull ups usually goes from 2.2 kilo ohm to 10K. So 5 volts and in a resistor in any range. Now, that is inactivating the cell, but for not enable also the output, I put here another connection. So when chip select is not activated, this means when it is in 1, this AND receives a 0. And it's the same case, read and write is not going to be the trigger. It's like this is always right, this is 0, this is 0, sorry, what I said, this is 0, and this gate is going to be inactivating the functionality. It's always going to be writing, not reading. So here we're gonna see third state, and if in practice, if I want to write a data, the cell is not going to pay to me because, as I said, the clock is not going to be receiving signals. In summary, if chip select is inactivated, I'm not going to be able to use the cell memory. If I try to read or to write, the cell is not going to obey me. I'm going to see third state at the output. Now, if chip select is activated, but my output is not enabled, I'm going to be able to actualize the data I'm writing. I can be writing, but I'm not allowed to read. Also, I'm going to see third state. And if both are activators, well, I can use the cell with any problem. I can read and I can write.